Discuss about the overhauling of electric motor and common troubles involved in it with remedies. Overhauling of electric motor. A standard electric motor overhaul includes an initial equipment inspection and diagnosis, bearings replacement, a test run and report. A sample motor overhaul work scope includes collection from site, inspection and record all relevant data from the nameplate, carry out electrical and mechanical check test to verify motor condition and any reported faults where possible. Dismantle motor, clean and inspect all component parts. Datum checks including bearings, journals and seatings, shaft expansion, shaft extension, run out, shaft seal fits, commutator diameter and brush surface length, repair or replacement of defect components and parts, steam cleaning, stove drying and varnishing of stator and rotor windings as specified by IEEE 1068. Rotating parts dynamically balanced to ISO grade 2.5 or better. Up to date motor plate fitted before dispatch, delivery, service to customer site and recommissioning. Common troubles and remedies of electric motor. Electric motors play a central role in machinery in every industry. A failure in this critical piece of machinery could be catastrophic to the business, with the potential for high cost and a long period of downtime. Understanding the common problems that can occur with electric motors can allow you to put measures in place to avoid failure and give your electric motor the best possible chance of achieving its maximum possible service life. Low resistance. Low resistance is the most common cause of failure in electric motors. It is also often the most difficult to overcome under conditions such as overheating, corrosion or physical damage. Degradation of the insulation of the internal windings of the motor may occur, and this then causes insufficient isolation between motor windings or conductors, leading to short circuits, leakages and eventually motor failure. Regularly inspection and insulation of the windings for signs of wear and replace before low resistance leads to failure. If you are unsure, consult an expert. Overheating is generally caused by either high temperature in the operating environment or poor power quality. It is responsible for around 55% of insulating failures in electric motors. For every 10 degrees Celsius that the temperature of a motor rises, the insulation life is reduced by half. To avoid overheating, ensure that electric motors are kept as cool as possible. This can be done by maintaining as cool an operating environment as possible and regularly checking the temperature of the motor. This can be done by maintaining as cool an operating environment as possible and regularly checking the temperature of the motor. Electrical overload is also commonly referred to as overcurrent. It is caused by an excessive flow of current within the windings of the motor, which exceeds the design current that the motor is able to carry efficiently and safely. Overcurrent is often the result of low supply voltage, which results in the motor drawing in more current in an attempt to maintain torque. Electrical overload can also be caused by short circuited conductors or an excessive voltage supply. It is important to install effective overcurrent protection which is able to detect overcurrent and interrupt supply to protect the motor. Vibration. Vibration can be extremely damaging to electric motors, frequently causing premature failure. It is often caused by the motor being positioned on an uneven or unstable surface. However, vibration can also be a result of an underlying issue with the motor, such as misalignment or corrosion. Electric motors should be regularly inspected for vibration causing a motor analyzing tool. Ensure that electric motors are positioned on a flat and stable surface. If vibration still occurs, check the signs of wear as well as misalignment or loose bearings. Consider contacting a specialist if the source of vibration cannot be easily identified. Contamination. Electric motors frequently operate in environments where dust, dirt, and chemicals are present, which may find their way inside the motor, leading to contamination and motor failure. These contaminants can dent bearings, raceways, and balls, leading to high levels of vibration and wear. They may also block the cooling fan, limiting the motor's ability to regulate its temperature and increasing the chances of overheating. As contamination is one of the leading causes of failure in electric motors, it is essential to prevent it from entering the motor. Luckily, this is relatively easy. Ensure that work areas, tools, and fixtures are kept as clean as possible at all times to help eliminate the chances of contamination entering the motor. When laying out the workplace, try to position motors away from applications such as grinding machines, which produce large quantities of harmful contamination. Electric motors are the driving component of a vast range of applications across every industry, and regular inspection is essential to reduce the risk of premature failure. If you are in doubt about the condition of your motor, it is always advised to contact a specialist for further investigation.